Back in 2.1, that assignment was a handout on Google Classroom. So you should also be able to answer questions about those graphs. Like, number one, which one is the graph of x squared? Do we all know what the graph of x squared looks like? Parabola. Okay, by looking at the graph, can you tell me the domain? So if I'm looking, my parabola is E, what's the domain of that? Negative, infinity, positive. What is the range? 0 to positive infinity. You should also, some of those questions, remember, would ask you things like, when is it increasing? So number 2, which one is the graph of the absolute value function? G, because we're looking for that V. Where is it increasing? Can you tell me where this graph is increasing? 0 to infinity. So you should be able to look at the graph to answer questions about domain, range, increasing, decreasing. All right, any questions about that? The second piece of what we did in 2.1 is probably the only thing that we have not used every day, so I do want to review that, and that is the symmetry piece. We did spend a whole day on it when we learned it, but let's review. Okay. So if I asked you to decide if 3x squared plus y equals x to the 4th. If I want to know if that is symmetric to the x-axis, how did we check that? Okay. We replaced our y with a negative y. Remember, if it's the same on both sides of the x-axis, whether y is positive or negative, it's identical. So if I put in a negative y for my y, is there anything I can do to turn that back into the original equation? No. So this one is not symmetric to the x. How do we check symmetry to the y-axis? Okay. So if I put in a negative x, what happens if you square a negative? What happens if you have a negative to the 4th? So that's back to my original. So that means this one is, yes, this graph is symmetric to the y. How do we check the origin? Okay, so if I did that, you get 3x squared minus y equals x to the 4th. Is that what we started with? No. Remember, is it possible to have more than one yes? Yeah, so if I had made my y also squared on that, then they would all be yeses, wouldn't they? So you have to check all three. You can't just find one that works and assume you're done. So we remember how to check for the 3 types of symmetry? Along with that, if it was a function, we said it's really even or odd with the terms that were used. Even is the same thing as symmetric to the y-axis. Odd was the same thing as symmetric to the origin. Alright, so if I wanted to check one of those, let's say I gave you f of x equals 2x to the 5th minus x. Okay, you could change f of x to y and do it the same as the last one. Or, we talked about if it's in function notation, it's really even easier. All you had to do was plug in a negative for the x. If you take a negative to the 5th power, do you get a positive or a negative? Minus a negative is positive. Okay, if it comes back to be exactly what we started with, then our function is even, because that means a positive and negative x gave us the same thing. If it comes back to be the exact opposite, That's like our origin. When the x is negative, the y became negative. So if you get the exact opposite, that's odd. This is the opposite of what I started with, so that was odd. So if it's identical to the original, even. If it's the exact opposite, odd. Anything else would be neither. Questions on that? So we talked about our parent functions, our symmetry, and then after that we just did our transformations. Is there anything else you guys want me to? So the next thing we are talking about is absolute value functions. We talked about the absolute value graph, so we've seen some of this, but I want to talk more about the function itself. What is absolute value? What does that mean? It's always positive. Right. So absolute value tells us a distance from 0, so it's always positive. All right. First, I want to look at what absolute value does to a graph. If I just asked you to do the absolute value of a graph, we'll look at a couple examples of those. Then we'll write down the rules for solving equations and inequalities, and that'll be where I stop today. And tomorrow we'll solve the absolute value equations and inequalities. If I asked you to give the domain and range of two different functions, okay, we could think about these. This first one, you might be able to tell me the domain and range without drawing a graph. But if not, we could always draw it. What's my parent function? X squared. 0 squared is 0. 1 squared is 1. Negative 1 squared is 1. Okay, if you wanted, you can do more points, but you don't have to. That's my parent. Right. What would the minus 4 do to my graph? And the minus 3? So if I move this graph right and down, take each point, right 4 down 3. It gets moved over here. What's the domain of that? What is the range of that function? Y start at -3 and go up forever. Do we agree with that? Okay, if I ask you for the absolute value, the only thing that will change on this is that negative section, because can you do, or what would be the absolute value of a negative? Positive. So what would happen is, if I said do the absolute value of this, the positives wouldn't change. These negatives would become positives. Okay? So your graph would really kind of bounce up like that because it's only positives. What would be the domain of that one? Yeah, it doesn't change the x's. The only thing that changes is the y's. We can no longer get out negatives. So my range would be 0 to infinity. You can only get out positives. Okay. Was the graph required on that? Not really. You could have gotten it without if you knew what those transformations were, and just knowing that the absolute value makes it positive. Any questions there? Let's look at this one. I'm giving you a graph. I guess I really didn't want to give you the answer, did I? Here's my graph. If I asked you to graph the absolute value, what happens to my graph? So this pink part would get flipped up, right? All of those negatives become positive. Okay, so what's the original domain? What's my original range? -3 to. Once I do the absolute value, the only thing that happened is this negative part got flipped up, it got reflected over the axis. So that never changes the domain, but what's my range now? All right. So do you understand in terms of a graph what absolute value is doing? Okay. Let's try drawing one ourselves. We're going to do a nice one. If I ask you to graph y equals 2x minus 1, what is that? A line. Y-intercept is -1, slope is 2. Okay, so there's my original. If I asked you to graph the absolute value of that, it wouldn't necessarily go away, but like this point was at 0, -1. Where would it go? 0, 1. Okay, this one would be like at -2, -2, so it would go to -2, 2. Does the positive part of my graph change? No. So when you do the absolute value, this stays the same, but that negative part gets flipped up.
So there's a ticket. We need to have these things. Okay, okay. He will probably come today. I don't know if it just needs cleaned. I didn't want you to think I forgot about you.
Thank you, I appreciate it. All right, so the only change is the negatives become positive. All right, so we can handle that. Last thing, I just want to get it written down in our notes. I'm probably not even going to talk about it today a whole lot. This will be what we're doing tomorrow. So, our rules for solving absolute value equations and inequalities. If it's an equation, absolute value measures distance from 0. So the number inside could have been positive or negative. So you set it equal to both the positive or the negative. If it's a less than, that is an and statement. There's a couple different ways to solve it, but what I usually do is set up a compound inequality. If the distance is less than a, that means your number has to be between positive and negative a. And if it's a greater than, that is an or statement. It has to be further than a units away. So it means it could be less than the negative or bigger than the positive. I want you to have this written down in your notes. That's what I'm going to pick up with tomorrow, and we'll actually look at examples.